All right, so this is graph number 3. Let's go ahead and start. Just like we did last time, this is a velocity versus time graph that we have here, and we are going to start by making the position versus time graph first. We said that that's going to be that we are going to look at area first to determine this, and it's always the area between the curve and the x-axis, which is that area right there. We'll divide it up into shapes, which are nice to work with. Something else I wanted to mention is that you should remember that the area is the displacement, because when you take the area, right, area is, say, base times height. When you multiply the base, which is time, by the height, which is velocity, you're going to get the area. Well, we can also remember that our formula, V equals delta x over t, which is our average velocity formula. We can rearrange this and multiply both sides by t. Let me grab a different color. Right, just like that. Cancel these t's right here. And we have delta x then, right, I'll rewrite it over here, is equal to t times v. And so you can see from that, right, that down here then, this is why the area is displacement, right? This is why this is the same as this. And so that's all we're going to do here. So, all right, so we got some areas to look at, but we have to split this into shapes that we're comfortable with. So this first one, we'll divide it up into a triangle right there, and then a rectangle right here. And let's see if I can make that look a little bit different than the triangle. And go from there. Notice that the units, or the squares, right, go over 10, and they go up or down 5. That's just something to notice. Let's go ahead and take the area of that rectangle. So we said the area, I'm just going to come down here. I think you can see this, is base times height. And so then the area is equal to the base of 10 seconds times the height of negative 5 meters per second. And this is another reason we can see that the area is going to give us displacement, right, or change in position, because when we cancel our units, we see that we're left with meters. And so we can then go ahead and write that the area of that rectangle is negative 50 meters. Okay, so we're saying that, see if I can, we're saying that that rectangle right there is negative 50 meters. All right, and then that triangle that's underneath it, area is equal to 1/2 base times height. Area is equal to 1/2. Base here is still 10 seconds. Height is, height goes from negative 10 or negative 5 to negative 15. Can you see that? Let me highlight that in green maybe. All right, that's the height of that triangle, right? From negative 5 to negative 15. So it's going to be a height of negative 10. Hopefully that makes sense. So negative 10 meters per second. 10 times negative 10 is negative 100. Once again, those seconds are going to cancel away. So we have half of a negative 100, which is just going to be negative 50. All right, so that triangle has the same area as the rectangle directly above it. And what we're seeing then is in the first 10 seconds, we are going to go negative 50 plus negative 50, or a total of negative 100 for those two areas. So in the first 10 seconds, so we can always assume, unless they tell us otherwise, that we can start at position 0. And so that's why I drew that dot right there at position 0. Maybe I should get a different color, maybe blue, just so maybe it doesn't blend in as well so much with the black. All right, so, and we're going to go forward or backward, however you want to say it. We're going to go in the negative direction to negative. We're going to change our position by negative 100. So in the negative direction by 100. Okay, so we'll go to right there by time 10 seconds. And just connect the dots right there. And I like to draw or write the number in just so I remember. This one's obviously 0, but that way I can keep track a little easier. Okay, so down here then for the next one, we're left with just another rectangle just like what we had a second ago. And we already took the area of that, right? That was negative 50. So this rectangle right here is also another negative 50 in the next 10 seconds. So we can say that by the time 20 seconds, we'll go another negative 50, which is right here, to negative 150. So we didn't go to negative 50, right? That's not what we're saying. We're saying we're increasing our position by 50 in the negative direction. All right, so we'll write a negative 150 there just to keep track. Then we're left with some kind of like little tiny triangle here. And I don't know what to do with this. All right, so hopefully you can see what I'm saying. Let me give it a little color here or something. Let's try and give it some lines. Okay, that tiny triangle right there. Now, I think its base is 5. That looks like it goes to about 25. And I think its height is negative 5. So let's just go with that. Let's get that tiny triangle. Area is then base of 5 seconds times the height of negative 5 meters per second. And we can go ahead and cancel some units. Let's cancel those seconds. And we're left with, but this is a triangle, right? I got to watch my area formula. Ooh, that was close. Area wouldn't be the first time I made a mistake on one of these problems. This is like one of the problems that I hate making a mistake on because the mistake is cumulative, meaning like if you screw up a part of it in the beginning, it just builds. And so I've done it before, and it's never a good thing. So I try not to. It's a little bit stressful. Negative 25 meters times a half, which is negative 12.5 meters. All right, so we're going to tack on 12.5 meters in the negative direction, right, for our area of that small triangle. Okay, so I'm saying this right here is negative 12.5. All right, so we're at negative 150, so we add on 12.5 more in the negative direction. That's going to get us to negative 162.5. But it isn't going to be at 30 seconds. It's going to be we only went forward 5 seconds, so it's going to be at time 25 seconds. So at 25 seconds, we're going to be at negative 162.5. Where is that at? I don't know. Let's see. Let me erase that little dot I just made. Probably about right here. This is definitely 25. It's in between 20 and 30. And then it's a little bit more negative, so it's not quite 175. It's not quite half. So negative 162.5. All right. Then we have no area, right, for the next 10 seconds. So if we have no area, that means we have no delta x, so no change in position. So we hold position. So I'm talking about this right here. Let me grab a highlighter and highlight in, I don't know, blue. Let's go blue. Let's highlight. Yeah, go blue. All right. So right there, that is 0 area right there. So that's what I'm talking about. So we're just going to go ahead and make that mean that we're going to stay for the next 10 seconds at that position. And that position is negative 162.5. And I'm just making a note there of it, just mainly, so everybody can see what I'm trying to say. And yeah, and that's good. Something that else is going to happen here is notice now we're going to have positive areas now, right? All the negative areas are done. And that means that we're not going to go, sometimes what students want to do is they want to have this line jump immediately into the positive part, right? This line that's dipped downwards into the negative, to negative 162.5, but that's not what this is saying, right? It's just saying that we're going to turn around and start moving in the positive direction. Now, it doesn't mean we're going to have a negative or a positive position. We might still have a negative position. Let me show you what I mean. Let's go ahead and take the area of this triangle right here. All right, so that triangle from 35 seconds to 40 seconds has a base of 5 seconds, a height of 10 meters per second. So we're saying area then is equal to 1/2 base times height. Not going to forget that 1/2 this time. 1/2, 5 seconds times a height of positive 10 meters per second, right? So we're going to have 1/2 of, cancel my seconds. My favorite thing to do is cancel units. I don't know why. It's just something, it's nice to do, right? It's, you're on the right path through the problem is why. So, whoa, what did I just do? What the heck? Not even sure how I got that. It's going to ruin my video right here. Okay, there we go. All right. Okay, 1/2, 5 times 10 is 25. So we're just going to say 25 meters. This is going to be a positive 25 meters, though. So what we're saying, this is displacement. So we're going to change our position by 25 meters in the positive direction. Well, if we go forward 12.5, that brings us back to 150. And then if we tack on another 12.5, I think that gets us to negative 137.5. If you got a calculator, you can check, but I think that's right. So we're going to say by time 40 seconds, we're going to be at 137.5. Well, here's 150. It's not quite 125, so maybe right there, right? Okay, and we'll call that negative 137.5 because 150 minus 12 is 138 minus another 0.5 is 137.5. All right, I don't know how easy that is to read. Let me zoom in a little bit. Maybe that'll... Oh, yeah, that's better. All right. Okay, so I think that's easy to see. Let me rewrite that one more time. Maybe I can do better. All right, that's a little bit better. All right, so then we are going to have some more area. Now, each one of these rectangles is still worth 50, right? In fact, I could, I just got rid of all my highlighting. That's okay. All right, so I'm saying we don't have to do this extra work here. This is going to be positive 50, that rectangle. And this rectangle is going to be positive 50. And then this one right here is a problem up on top. How are we going to deal with that? Boy. We could just say it's 48, but that's probably not the best we can do. I think we can do a little bit better. Maybe 45. Let's do the work here. So we know a whole rectangle is 50, but this thing isn't quite 50, right? Because this little piece right here is missing. So how are we going to deal with that? Well, what's the base of that? Looks like it's a triangle, right? So what's the base of that triangle? I'd say about 2 seconds. What's the height? Maybe half of 5, so 2.5. Let's just go ahead and calculate the area of that as best we can. All right, so we have area of this triangle is equal to 1/2 base times height. Area then is equal to 1/2. The base was, we said 2 seconds. The height we said is 2.5 meters per second. All right, we'll go ahead and cancel off seconds. All right, so far so good. Go ahead and multiply that across. 1/2 times 2 is 1. And 1 times 2.5 is just 2.5. So we're saying that area that's missing is worth 2.5 meters. So I'm saying if an entire box is 50, we can just subtract that missing positive 2.5 meters, right? And so we get 47.5. All right, hopefully that makes sense for why we're going to call this box, well, it's not really a box, but this area right here, 47.5. Okay, so in the next 10 seconds, we're going to go forward 147.5. We are at negative 137.5. So I want to say then we should be at positive what? Think about that. We're going to go forward 147.5. We're at negative 137.5, positive 10. All right, so let's go ahead and put a dot up there at positive 10 where we think it is. So positive 10 will be above 0, and time will be at around 50. We'll be at 50. So I'm going to write positive 10 right there. And connect the dots. Okay, good deal. Right here, going forward, once again, trying to make our life easy. Why do we have to keep doing these areas if we don't have to write the math if we know how much these boxes are worth? This looks like half a box right here, so we can say this is positive 25. All right, so we're going to go forward 125 in the positive direction. We're at 10 in the next, so hopefully that's making sense what I just did. We're getting this area right here in orange. Okay, so we're going to go forward positive 125 from 10. That's going to be 135. 135 by time 60 seconds. Where's 135? It's about right here. Let's go ahead and label it. All right, that's 135. I don't know if you can see that. I can do better than that. All right, good deal. Now we have a triangle right here. And really we got two triangles that are going to be equal and opposite. So if we get one of these triangles, we'll have the other one. Now, we're talking about this triangle in purple right here. Really, though, I think this is the same as this triangle on the other side. It doesn't quite look the same, but it's pretty dang close. And so I'm saying this purple triangle right here, which we already took the area of, right? It had a 5-second base, a 10 meter per second height. That's really the same as this purple triangle over here, right? A 5-second base right there, a 10 meter per second height. You might say, well, it looks like it's kind of cutting off a little bit of that box there, and you might be right. But this is where it's not an exact science. And so on your test, I would make sure that I try not to give you questions like this. I try and give you questions with exact answers because I don't need kids arguing with me over questions, right? I got better things to do than give you guys vague questions and hear you argue for test points, right? So I try and give you exacting questions that have, right and wrong answers that way it's easier to grade, right? And it's a fairer test. So anyways, we are going to say that these two triangles are the same right here, these two purple triangles. So what was the area of that before? Let's see here. I think it was a 5-second base with a 10 meter per second height. So I think it was this one, right? Positive 25. Okay. So then we can say that if this is positive 25, oh boy, then what's this one down here by that same logic? Negative 25. Okay. So, all right. So up on our graph here, even though in the next 10 seconds, it's not, I like to split this up because I want to show maximums and minimums on my graph. So here's a case where I wouldn't just say, well, it doesn't do anything in the next 10 seconds, right? It just holds position. And while technically that's true, we're going to end at positive 35. We want to add in this positive 25 because, so if we add in positive 25, that should put us at what, 160? 160 at 65 seconds. So 160 is about right here. Oh, I still have purple. Oh, blue. Okay. So we're saying right there. So the reason we want to do this is because it's going to show a maximum on our graph. And that's why that's super important. And you don't want to just draw a straight line across to 70 and say, oh, there's no change in position. Hopefully that makes sense why, right? We like seeing maximums and minimums on our graphs. I think it tells us something. It's useful. So we know by 70 seconds, though, it's going to go negative 25. So it's going to then go back to 135. All right, something like that. And we get to see that maximum, which occurs at 65 seconds, which is super important. And then that's good to know. So then we got a final 10 seconds of this area right here. Let me show you. It looks like two squares or boxes. So this is going to be worth negative 100. Base there is 10 seconds. Height is negative 10. 10 times negative 10 is negative 100. Meters. So let's go ahead and add that negative 100 meters on. So we're at 135. So we should go, we're going to go 100 meters in the negative direction, which means that we're going to end at positive 35, which is about, and this is at time 80 seconds. Dang it, why do the eraser on? Just about right there. Call that positive 35 meters. All right, that's great. Okay, I'm going to pause it there and take a little break, and then come back and do the next part of this problem. All right, so now let's make this acceleration graph, and for here we're going to talk about slopes. And so to do this, let's see, we'll start with finding this slope right here. Oh boy, all right, the highlighter's a little thick. All right, anyways, okay, so we'll try that. And we're going to need 2 points on this line, so I'm just going to grab the end points. So I'm thinking maybe this point right here and this point right here, right? These points at the end. And so it looks like, let's go ahead and write our formula for that. So we have, just draw a little line right here. So we have acceleration is equal to delta V over delta T, right? And we're going to separate that out into VF minus VI over TF minus TI. And here I like to do the times always first. So my final time is 10 seconds. My initial time is 0. So I'll just go ahead and add that in. I got always get a positive value on the bottom. And then the velocities that go along with that, looks like my final velocity is at -5 and my initial velocity is -15. This is an up and right slope right here, right? And so we expect that to be a positive slope. So final -5, initial -15. So something like that. So we're going to end up with what here? We have -5 plus 15, which is 10 meters per second. And then on bottom, 10 seconds. So we're saying we're going to get 1 meters per second, right? Okay, +1. So let's then go up here. And we can go ahead and find +1. And we're just going to go ahead and use open circles. We're not going to worry about closed or open or whether or not it's closed. We'll just go ahead and make them all open and go with that. So, and that's in the first 10 seconds. All right, good. And then we can see right here, let me go ahead and switch to red here. Go ahead and see that slope right there is going to be 0. So that's the next 10 seconds. So we're just saying right here, between 10 and 20, we have that blue line right there at 0. Then we have another positive slope, right, let's see, right here. I guess I could go back to that, try that dark blue again. All right, right there between 20 and 25. Let's go ahead and get that slope right there. So I have acceleration is equal to VF minus VI. Let's just write the times down. I think it was 25 was our final time. And whoops, I don't know what I'm writing there. 25 seconds minus 20 seconds, right? I'm just using this formula right here. Right, I'm using it down there. So let's go ahead and then what about for the final velocity at 25 seconds? Well, it looks like at 25 seconds, our final velocity is actually going to be 0, right? Does everybody see that? And then at 20 seconds, our initial velocity is -5. So we're saying 0 minus -5. Once again, we should be getting something positive here, because it's up and right. So we get something like that, which is going to be +5. It's minus a negative. And then on bottom, 5 seconds. Not sure what that is right there that I just made there. So this is going to be 1 again. Okay, that's good so far. Let's go ahead and put that on there then too. And this is only for 5 seconds that we're going to be at +1 again. So just right there to 25. Then from 25 to 35, we have this flat line up here, right? Right here. So this is just going to be 0 slope again. And so that's convenient. Just go right back to 0 all the way to 35. Open circles there. And so far so good. Now we have this, I'm going to use some orange here. This slope right here, this positive slope. So let's go ahead and get some points for this. Time-wise, it looks like it goes from about 35 seconds to, I don't know, I'd say maybe to here, to 42, right? Because up here, right, it continues all the way to that point right there. So maybe 42 minus 35, right, for our times. Let's go ahead and write that in. All right, let's get some velocities. At 42, looks like we're at positive 15, and at 35, we're at 0. So we have 15 minus 0. This should be positive as well. All right, what is that going to equal? We get 15 on top. It's like 7 on bottom. 15 divided by 7. What is that? Boy, I think it's 2.14. All right, we'll go with that. All right, I have some notes sitting up here. I couldn't do that in my head. I don't know, maybe you can. 2.14 meters per second, assuming my notes are right that are up here. All right, so, and that's positive. So let's go ahead and add that in here. Get the blue out again. Whoops. All right, positive 2.14, which is about, and this is going to go to 42. So we're saying about right there. I'm trying to draw an open circle. Let me try that again. 2.14. It's about right there. All the way to 42, from 35 to 42. Okay. All right, that's good. Then, looking back up here, the slope becomes 0 again right here, right? All the way from 42 to 50. So that's nice. Okay. Added that down below on the acceleration graph, another 0 segment. And then we have a negative slope from 50 to 60. And what is that going to be? Almost looks like maybe a -1. Let's go ahead and calculate it though. Looks like it's going to occur over, let's see if I can show you what I'm talking about here. So this orange line right here, right, it's going to occur over a time period from 60 to 50. And the height is going to go from, what is that? Final would be, so it's going to go from 15 to 10. So it's going to be, 10 will be the final, and initial velocity will be 15. All right. So I'm saying, let me write that out. So we have acceleration equals 60 seconds minus 50 seconds. And I believe it's going from 10 to 15. So we're saying 15 meters per second will be the final, and 10 meters per second is the initial. I think I have that right. Let me just double check really quick. Yeah, 10 minus 15, 60 minus 50. Oh, so I have those out of order. All right, good thing I checked. It's getting a little late here. So, a lot, I guess, more likely to make a mistake like that. All right, so something like that, right? Our final velocity is 10. So we're getting a negative slope here. So we're going to get negative 0.5 meters per second per second. All right, cool. And let's go ahead and add that. And it's all the way to from 50 to 60. All right, good. Now let's get the steeper negative slope. This one's going to go all the way from 60 to 70, and it's going to be over a large change in velocity, right? It looks like it goes from positive 10 to negative 10, Negative 10 would be the final. So, all right. So I think what we're saying here is this then. So we're saying from 70 seconds to 60 seconds, right? Or 60 to 70, so 70 minus 60, final minus initial. And then we're saying the final is negative 10, and the initial is positive 10. And this should be a negative slope, so let's see if that's going to give us negative 10 minus 10 more. It's going to be negative 20. That checks out. And then we got 10 seconds on bottom, so we're saying negative 2 meters per second per second. All right, so this is going to equal, let's add this in. So we'll put this right, let's see, 0.5, I think right, how's this graph work? Negative 1, negative 1.5, negative 2 right here. Whoops, my eraser's on. So negative 2 right here. Yeah. All right. So far, so good. And then the last part's super easy, right? Just 0 again right there from 70 to 80. Let's add that in. Okay, and there we have it. Let me go ahead and highlight a little bit here so you can see this hopefully a little clearer. A little yellow, amazing blue. Go blue. All right, so you should be able to see all those accelerations, and this is our acceleration versus time graph. And yeah, looks good. All right, so we're almost done. Last part is to use the velocity versus time graph to answer these questions at the top. So let's remember, so when the velocity is positive, we're moving forward. When the velocity is negative, we're moving in reverse. When the velocity is 0, we are stopped. When the velocity is going away from 0, we are speeding up. When the velocity is towards 0, we are slowing down. And when our v is constant, a hard time spelling constant, we get constant speed. All right, so let's go ahead and shade this in, right? Go ahead and use orange. All right, so forward or positive velocity, negative velocity, and stops. So it looks like, looking at our graph here, that from 0 to 25, we have a negative velocity. From 0 to 25, right, for time, we have a negative velocity. All right, so 0 to 25, I'm going to use this graph underneath here, this position versus time graph, just to line it up, right, and find 0. So we're saying right here, 0 all the way to 25. Where's 25? It's about right there, right? So I'm saying that all of this is going to be negative velocity. Then also, what's special about 25 is that we are stopped there, right? We're stopped from 25 all the way to 35 because the velocity is 0. So from 25 to 35, we are to stop. So from here to say here. You see what I mean about lining that up? I hope you do. Check this out, right? Look, I'm lining this up to 35, and I'm lining this up to 25. All right, that's what I'm doing. Okay, I'm going to erase those purple lines if I can. Oh, it's a mess. All right. Okay, so let's go ahead and shade that in. All right, and then what happens after that? Well, from 35 all the way to 65, we have positive velocities from 35 all the way to 65. Okay, so from 35 to 65. So we're saying from 35, where's 65? Right about here. 65, I think it's going to hit 0 again. So we're going to have some kind of stop there at 65. All right, anyways, from 35 to 65. So here's 35 to 65. All right, looks good. Then at 65, there is a stop happening, right? Because we cross 0. Hopefully everybody can see that. Talking about right here, this blue circle I'm making, 65, right? You are going to stop for a brief second. Why do you have to do that? Well, you have positive velocity before that, so you're moving to the right, say, and then you have negative velocity after it, you're moving to the left. Whenever you switch directions, you do have to come to a stop. Even if it's just an instantaneous stop, if it's just super quick, but you have to stop to change directions. That should make sense to you, right? In order to turn around and change directions, you have to stop. All right, so anyways, there's a stop at 65, and then it's all negative velocity from there on out. All right, so we got the stop at 65. It's already on there. It's right here, right? And then it's all negative velocity after that. Okay, so something like that looks pretty good for our first 3 lines of the graph. All right, the next 3, speed up, speed down, and constant speed. All right, let's look at this one, speed up. Speed up is when we're going towards or going away from 0. Is that the first one, speed up? Yeah, so we're going away from 0. Well, if we look at this down here, we should be able to see, this is such a mess. So this from 0 to 10, right? Right here, from 0 to 10, I don't even know if that's making it any better. Right here, right? We are going towards 0. So this is a slow down, right? From 0 to 10. 0 to 10 seconds, we're slowing down. Okay, so speeding down from 0 to 10, right here. Okay, and then from 10 to 20, we have a constant -5. So we're holding speed from 10 to 20. So we're got constant speed here from 10 to 20. All right. Then from 20 to 25, we are slowing down some more. We're speeding down. We're going towards 0. So 20 to 25, speed down. Where's 25? It's halfway between 20 and 30. So right there. Okay. And then from 25 to 35, we have a constant speed that is 0. We're stopped, but we were holding that speed. So that's from 25 to 35, we have a constant speed. All right, so 25 to 35. All right, right there. So we have a constant speed. Then from 35 all the way up to, 42, we are speeding up from 35 to 42. I'm talking about this orange and purple line right there, right? That we are 35 to 42 speeding up. All right, 35 to 42. It's maybe about right there. Okay, 35 to 42. All right. And then from 42 to 50, right here, let me see if you can see this. 42 to 50, we have a flat slope, so we have a constant speed of 15 meters per second from 42 to 50. All right, so constant speed from 42 to 50. All right, good. Then this is interesting. So right here, we are speeding down. We're making this wavy line, right? And even though there's two different slopes there and they're both negative, we are slowing down in both of them. But then underneath that, right here, we are speeding up. Sure, we're going in the negative direction. Our velocity is becoming more negative, but we're speeding up from zero, from stop. So, okay. So we're saying we're slowing down then. Let's go back and graph this. Slowing down from 50 to 65, right? Where we have this wavy line from 50 to 65. Okay, let's go ahead and put that up here. So from 50 to 65. Okay, so about right there. We're slowing down. And then from 65 to 70, right here, right? We're speeding up. So 65 to 70. Okay. And then finally, we have a constant speed right here, right? So that's constant speed of negative, or speed of 10 actually, the constant velocity of negative 10. And that's from 70 to 80 that we have constant speed. All right, and that's about it. So let me zoom out a little bit. It's getting kind of hard to see all that together. So it looks like something I always mention is that you did this right if at the very end with this, say, these 3 orange lines and the 3 black lines, that you can push all the lines together and create one completed line, then you did it right. But that's usually the best way through it, is what I described there. You just got to remember what forward is positive velocity, reverse is negative velocity, v equals 0 is stop, and v away from 0 is speed up, v towards 0 is speed down, v constant is constant speed. That's about it. Let me know if there's any questions, and you're going to do number 7 tomorrow on your own, or the next time on your own, and hopefully that goes well. All right. Anyways, have a good day, and talk to you later.